And here we go. All right, Dawn. So thank you for joining today. It's a pleasure to meet you. I would love to kick this off before we even talk about your work and some of your incredible findings about the nature of reality and the implications that has for us and how how we can differentiate our own observations from the truth behind those observations. I'd like to ask you about yourself and how you came into this field in the first place. I mean, what inspired you? Take us back as far as you'd like, maybe before college.
Oh, well, sure. Thanks. Thank you for the kind invitation too, Jake. I appreciate being on your podcast. I think I've been interested in this for quite a while, the nature of reality and how we fit into that reality. I got My father was heavily into Christianity and was a minister, Protestant fundamentalist minister. So I got that view of the world on the weekends, and I got a different view in my science classes at school during the week. And so there was an obvious disconnect, and I was very interested in trying to figure out for myself um, what what was going on here and how to make the an understanding of this. And I think a lot of people have that same disconnect that they have to try to figure out for themselves. And so, even as a teenager, I was thinking about the philosophical issues about are we just machines? Are we just physical systems that are machines? And if so, could an artificial intelligence, properly programmed, be effectively just as human as we are and just as conscious as we are? Or is there some, you know, elan vital, some special thing about us that makes us that can't be captured by artificial intelligences? And so, so I was, I read on both sides. I read the science, I read the Christian literature, mostly the Christian literature at that time. Since I've broadened out a little bit and looked at other religions as well. But but back then, you do what you have at hand, and and then I eventually went to MIT as a graduate student in the artificial intelligence lab to understand what AIs could do, and how far can we go with AI? Can we make conscious AIs? And I was also in what's now the Brain and Cognitive Sciences department, so I was studying human cognitive neuroscience to understand the human side of the equation. So I was, my graduate work at MIT was really again motivated by trying to figure out: are we just machines, or is there
Mhm.
something beyond that? And so that's sort of a little bit of the background and how I ended up where you are right now in the MIT area.
Yes. And what did you find out?
Well, so the when I was a graduate student at MIT, which was from 1979 to 1983, we weren't really allowed to talk about consciousness. And it wasn't really, if you talked about consciousness, that wasn't considered scientifically respectable at the time. Now you can, and very, very, it's very mainstream for science to take on consciousness. But yeah, that was the time. And now there are lots of theories of consciousness and lots of progress in artificial intelligence beyond what we had at MIT in 1983. The field has really moved on. And I would say, to summarize what we've learned so far, is our theories of consciousness that assume that a physical system, such as a brain or a computer or an AI, somehow generates conscious experiences like the taste of chocolate or the smell of garlic or the feeling of a headache or something like that, those specific conscious experiences, or just awareness, period. All of our attempts to come up with mathematically precise theories have so far, I mean, they're interesting and these are my friends and colleagues, they're brilliant. But if I were to ask, is there a specific conscious experience that any theory has been able to, even one, like just the taste of mint or whatever, can any of these theories give you the mathematical, precise statement from their theory about what, for example, what integrated information must be the taste of mint and couldn't be the taste of chocolate, or what orchestrated collapse of quantum states of microtubules must be the smell of garlic. What's remarkable is despite the brilliance and hard work of my colleagues and friends, there's not one experience yet that can be explained. Not one. So we're batting zero, literally zero on precise
Maybe,
content. So right now we don't have any idea how physical systems could give rise to conscious experiences. Literally nothing on the table that works.
yeah. So what would it mean for it to work? Like when you say nothing, so to take that that field of thought, your colleagues who try to prove that a physical system can generate a conscious experience, to reiterate what you're saying is in trying to prove that or come up with a case where that happens, like they're trying to prove it in the case of mints, like what do you mean exactly? What would it mean for, like, let's say one of your colleagues did successfully prove that a physical system can generate a small conscious experience? What does that proof look like, or what would that mean?
Right. Right. So each scientific theory, scientific theory tells you up front what its assumptions are and what it's going to try to explain. So for example, in integrated information theory, they're going to assume some kind of functional architecture, a system with functional architecture. It could be a physical system. In some versions, they'll say that it doesn't require physical systems, but it's going to require some kind of computational architecture, and that they can evaluate the information flow in that and what they call the integrated information in a system. And so that's what they're going to assume is the starting point. And then what they want to explain is conscious experience, the emergence of consciousness, period, and also specific conscious experiences. And of course, no one told them they had to do that. I mean, but what they're saying is, we're going to start with these functional architectures, and we will give you conscious experiences. So that's their choice to take on that problem. And I should say, by the way, that this is different than just finding that this part of the brain is correlated, its activity is correlated with this kind of experience, right? These are the so-called neural correlates of consciousness. Those are the data that need to be explained, but those are not theories. So I want to be very, very clear. Finding neural correlates of consciousness is great, and it's important, and my colleagues are doing that, and but that's data, that's not theory. And that's the data to be explained. So these scientific theories, that like the integrated information theory, have set themselves the task of starting with a functional architecture and then telling you when it will give you conscious experiences and specific conscious experiences. And the bottom line is they set themselves a problem and they can't solve it in terms of specific conscious experiences. Now, they do have, in the case of integrated information theory, they have a paper where they develop what they call the Q shapes, the qualitative, the qualia shapes that come out of their theory. And but in terms of actual specific Q shapes, like for the taste of chocolate or the smell of garlic, I asked Tononi back in late 1990s to give me an example, and he couldn't. And I asked him a couple of years ago to give me an example, and he couldn't. But they have a paper recently about the Q shape for space perception, so the experience of space, which you could think of as a specific kind of conscious experience. I'm not convinced, because for example, there's visual space. But if I'm blind, I don't have a visual space perception, but I might have an auditory space perception. And if I'm deaf,
Yeah.
I might not even have an auditory space perception, but I might have a somatosensory space perception because I can move around. And if I'm a bat, I might have an echolocation space perception. So space perception is not one thing. It's a particular kind of experience, and it's spatial or somatosensory or auditory or echolocation experience. So which of those must their Q shape for space be, and what is the principled reason why? So, and this, my same argument here would apply, for example, to the orchestrated collapse of quantum states of neuronal microtubules, Penrose and Hameroff's theory. Again, if you're going to explain specific conscious experiences, what is the precise orchestrated collapse of quantum states of microtubules in neurons? That must be the taste of chocolate. And I've asked Stuart Hameroff, in public forums, to give me an example, and they can't. So, and this is not just those two. Oh, and by the way, I should say there are some theorists that say, well, the conscious experiences and consciousness itself is an illusion. So my friend Keith Frankish says this, and Dan Dennett, and Michael Graziano's theory of attention schema. They'll say that
What would be the
experiences
thing observing the illusion?
I'm sorry?
What would be the thing observing the illusion if the perception itself, if the ability to perceive is consciousness? So what would be the lens of the illusion if consciousness itself was an
Well,
illusion?
they would argue that the ability to perceive is not consciousness, right? That consciousness is just wrong-headed. And so what you have are higher order brain processes, for example, in Graziano's thing, the higher order brain processes associated with attention that are sort of monitoring lower order processes, say from perceptual pathways in the brain, and giving you a description of those. And so then the feeling that we are actually having conscious experiences is just an illusion. It's just brain processes monitoring brain process, they would say. And you might say, well, so they are escaping the problem I just raised about specific conscious experiences, but absolutely not, because from their point of view, they're saying what we're claiming is that there are brain processes, say attentional brain processes, that are monitoring low-level processes that are giving you the illusion of, say, the taste of chocolate, or giving you the illusion of mint. Well, now the illusion of the taste of chocolate is very, very different illusion than the illusion of the taste of mint. So as a scientist, I want a theory. What precisely are the attentional processes that are associated and the neural processes that must be the illusion of the taste of mint and could not be the illusion of the taste of chocolate? So they, no less than those who buy consciousness, owe us a mathematically precise theory, and none is on the table. So the illusionists, it might seem like they've escaped the problem, but they are also batting zero in giving us any precise theory of any specific illusion of any specific conscious experience. So I'm not saying it can't be done, but I'm saying I know these colleagues, many of them are geniuses. These are brilliant, brilliant people. I would think that if it could be done, we would have made more progress than batting zero.
Yeah, well, and your theory in opposition to their theory is that rather than the physical system generating the conscious experience, it's the conscious experience that comes first. Can you talk about that?
That's right. So it's a matter of strategies in your scientific theory, right? So one strategy is to say, I'm going to start with physical stuff or functional stuff and try to give you consciousness as emergent. And so far, that just hasn't worked. I mean, it literally has not worked for one specific conscious experience. So another strategy is to say, well, let's go the other direction. Let's start with consciousness and conscious experiences as our fundamental starting point. And then let's try to show how space, time, and what we call the laws of physics emerge from the dynamics of consciousness. And so that's the strategy that I'm taking. And one might say, well, we know that space and time in the physical world exists. And this consciousness stuff is just airy-fairy. Who knows whether it really exists? You're taking the wrong framework. Well, there's a couple of things to say about that. First, the physicists themselves are telling us that space and time, or their union under Einstein into space-time, which has been an incredible framework for physics and science for a century, a little over a century in case of space-time, and several centuries for space and time. That framework is now at its end. As the physicists will say, space-time is doomed. So David Gross, Nima Hamed, Nathan Seiberg, and others are saying space-time isn't fundamental. We need to find something beyond space-time. And that means that objects inside space-time aren't fundamental. That includes brain processes, neural activity, and particles inside, the quantum states of particles and neuronal microtubules. Okay, all those things are inside space-time. And physicists are telling us that that's not fundamental. And my own work with my own collaborators on evolution by natural selection agrees. Evolution actually entails that space and time cannot be fundamental. and objects inside space and time cannot be fundamental.
Oh,
It agrees with the physicists.
and to
So
elaborate more,
yeah,
no, no, as you were saying. So sorry to interrupt you. But so to elaborate on the idea that consciousness is the fundamental entity, is that to say that, you know, consciousness is the lens, it is the fundamental principle, the fundamental entity? It's not the case that there's this physical world that we can observe through consciousness. It's that there is consciousness, and through consciousness gives rise to what we perceive. Because how else could we perceive what we perceive without consciousness? If only consciousness can perceive the grass and the trees and the oceans, then without consciousness, do those things exist? Is that the idea, or can you elaborate
sure.
or expand on the theory of consciousness as the basis of reality?
Yeah. So the idea would be, as a scientist, is to take our informal intuitions about consciousness. I'm aware. I have headaches. I taste things. I smell things, and so forth. And say, can we talk about those experiences and put some mathematics to it? And so that's what we're doing. We have a theory that we call the theory of conscious agents, and it's, you know, a conscious agent has a set of experiences available to it, and based on those experiences, it takes chooses what action it's going to take, which will affect the experiences of other conscious agents. That's sort of the top level of the idea. So there are these conscious agents and each agent has its own repertoire of experiences that it can have, and a repertoire of actions that it can take on the network of conscious agents to affect other experiences. So think like the Twitterverse, right? So you have a bunch of Twitter users, and they tweet and you follow. So I might follow some people and then retweet or not. So when I tweet something, I'm affecting the other Twitter users, and if they sometimes they'll then choose to retweet something I did. And so you have this vast social network, and you have a flow of ideas and experiences going through the network. And so that's sort of what I'm proposing, is that there's this vast social network that we call conscious agents, but it's mathematically precise. And we can use the tools of graph theory and graph analysis and social networks to analyze it. So it's a mathematically very, very rigorous kind of approach. And then the idea is, where do space and time and what we call the physical world emerge? Well, when you have something like the Twitterverse, where there are millions of users and billions of tweets, it's impossible to grok the whole thing, right? What you would like is some dumbed down user interface to give you a feel about what's trending here or what's going on. And so you need a user interface to help you simplify the billions of tweets and millions of users into something that you can actually manipulate and understand. And so you might have some kind of user interface, maybe even like a VR headset that you use to we'll probably be using that in the metaverse very, very soon, as a way to navigate it. And that's what space-time is. It's simply a simple headset that allows us to navigate a reality that's far more complicated. We have 4 dimensions, 3 of space and 1 of time, maybe 11 in string theory. But we have, you know, a small number of dimensions in space-time. But this network of conscious agents has countless dimensions. It is really, really complicated. So space-time is a fairly trivial headset, a data compression scheme that conscious agents, some conscious agents use to grok this network. But I countenance the possibility that there are countless other headsets, maybe a 20-dimensional or a billion-dimensional headset. Why stuck? There's nothing special about our space-time. My guess is that we have a fairly cheap, low-cost headset, as far as the ones that are possible. Physicists tell us that space-time headset actually falls apart at 10 to the minus 33 centimeters. Not 10 to the minus 33 trillion centimeters, just 10 to the minus 33 centimeters, and 10 to the minus 43 seconds, what they call the Planck scale. So we have a cheap headset that falls apart fairly quickly. It's very shallow.
Cheap
4
meaning
dimensions.
like this is how our consciousness perceives the world. And
That's right. It's the interface.
It could have a better, a higher fidelity headset. But our human consciousness? This is the
That's right.
fidelity. Yeah.
That's right. So we have, I think we have one of the cheaper models that are possible. Yep. Now, I should say, there are some people would say, well, you're making some exotic hypotheses. You're talking about all this stuff outside of space time. I feel much more comfortable just dealing with particles in space time. That's something we know is there, and so forth. And I would say just two things in response. One is that something that Steven Pinker has noted. He likes the global workspace theory, which says that, again, space and time is fundamental, and certain features of, say, brain activity or computational systems more generally, where you have a working memory that has certain connections with the rest of the computational apparatus, the contents of the working memory are in some sense going to be conscious. But he points out that in his book Enlightenment Now, the 2018 book, that the relationship between the computational architecture or the computational state and specific conscious experiences can't be predicted by the theory. So you might have to stipulate, he says, and he uses the word stipulate, that the taste of chocolate corresponds to this, the taste of mint corresponds to that. And I agree with him. I think Pinker is right. Pinker's a genius, and on this one, I think he's got it right. These theories that I've said, they cannot explain a specific conscious experience. They have to stipulate them, and I think that's principled. And it's not one stipulation; it's millions of stipulations. I need to stipulate something for mint, the color red, the color green, the taste of chocolate. So every experience, you're going to have a stipulation that this functional property or this functional architecture or this computational state corresponds to. So you have stipulations all over the place. So you're stipulating space and time, you're stipulating a functional architecture, and then you're also stipulating the conscious experiences. That's the way it is. I'm saying I'm only stipulating the conscious experiences.
Yeah.
I'll give you back the space time and the functional architecture as something that I can explain and not stipulate. So, using Occam's razor, I'm better off because I have fewer assumptions and I explain more.
Based on Occam, yeah. If we only have access to our level of consciousness, how can we even assume other more expansive, more complicated levels of consciousness? Like, are we not limited by our own consciousness to be able to imagine other types? And in imagining another, in other words, wouldn't being able to picture or understand a high level of consciousness require that level of consciousness to understand it?
That's a great question, and there's a couple directions that we can go in it. First, I agree. We are limited in our consciousness. Try to imagine a color that you've never seen before.
Right.
A specific color you've never seen before. Right.
Nothing
happens, right?
That's basically what I'm asking. Yeah.
Right. You can't do it.
And the second that you do imagine that color, you're now seeing the color. So if you either can't imagine it or you can, and if you can, then it's no longer a color you've never seen because you've seen it, right?
That's right. And so we can look at some clues from within our own headset. So one of the clues about color perception is that we only have 3 cone photoreceptors types in the human eye, typically.
Yeah.
But pigeons have 4. So you can imagine that pigeons have a dimension of color experience that humans don't. And there are some women, they're called tetrafems, that also have 4. There's not a lot of women, but there are women, and they've been tested. A friend of mine, Kimberly Jameson, has done a lot of good research on this. And these women have 4 cone photoreceptors, and good psychophysical evidence from Kimberly's group suggests that they actually have a new dimension of color experience that no man and most women could never even concretely imagine.
Huh.
So we have hints that our range of experiences is not all that's possible. It's probably a trivial subset of what's possible. And how do we go beyond it? This is where mathematics comes in. It's very, very helpful. So, for example, I can imagine a 2-dimensional square, no problem. I can imagine a 3-dimensional cube, but now try to imagine a 4-dimensional cube. Well, nothing happens. I just can't do it. But using mathematics, we can talk about all the properties of a four-dimensional cube, and we can prove theorems about it in five-dimensional and n-dimensional cubes. So with mathematics, we can actually go places where our own experiences cannot. And so mathematics turns out to be, that's one reason why it's so powerful in the sciences, that it takes you where your own concrete experiences fail.
Yeah, interesting. So what then is the truth of reality? Does our you believe you've shown that our consciousness does not successfully capture reality, the truth of reality. So how do we approximate reality, or how do we think of what reality really is?
Well, now this gets to the question of science and what are scientific theories, right? Because I'm a scientist, and my only answer could be a scientific theory, right? That would be like a theory of everything. But what are scientific theories? Scientific theories always say, grant me these assumptions. So you list your assumptions. And say, if you grant me those assumptions, then I will explain this range of phenomena. And that's what a scientific theory does. It says, grant me these miracles. We call them assumptions, but they're miracles for the theory. And if you grant me those miracles, then I will explain all this other fun stuff. But that means that there is no scientific theory of everything. Because you can always say, well, you haven't explained everything because you haven't explained your assumptions. You say, oh, well, I'll give you a new theory which explains those assumptions. But the new theory will have its own new assumptions. So my take on this is that, first, science is one of the best tools that mankind has for exploring reality. It's an incredibly powerful tool. But second, there cannot be a theory of everything. And my guess is that reality infinitely transcends, not just a little bit, but infinitely transcends anything that any scientific theory could say. And this is a double-edged sword. On the one hand, it might sound discouraging. It's like, holy smoke, I mean, we're going to be fundamentally ignorant, and I think so. On the other hand, it's in principle infinite job security for scientists, which is great news. So
yeah. Oh. I mean, so have you, through your work, have you gained a greater sense of what reality is? I don't know if that's an opaque question, but in other words, have you gained greater insight or clarity as to, okay, these things that I'm seeing and perceiving, these are figments of my consciousness. And have you been able to glimpse or understand what the next layer of reality is or looks like? Or
right. So one aspect about reality that our theories can tell us something really important about is the limit of our current theory. Right. So Einstein's theory of space-time, together with quantum theory, which also is, assumes that space-time is fundamental, tells us that, space-time is an incredibly powerful concept, but it falls apart at 10 to the minus 33 centimeters. It stops. It loses all steam at 10 to the minus. So beyond 10 to the minus 33, that game is over. And now that's a true fact. That is, we can nail that down. That is a fact. So we can know facts about the limits of our theories, and that's important. We can never know positive facts about the ultimate nature of reality, but we can know, we can
limits.
constrain.
Yeah. But that doesn't give you insight into what, that doesn't give you closer approximation or insight about real reality.
Right. So the way I think about it is, once we find both the scope and the limit of our current theory, like space-time falls apart at 10 to the minus 33 centimeters, then we can say, okay, what new framework, new assumptions can we posit beyond space-time? And what projection of that framework into space-time can we propose that will give us back the physics that we know inside space-time, make predictions that we can test? Right. So in other words, the current physics and chemistry and so forth that we have inside space-time is going to be a constraint on any deeper theory that we come up with. Whatever deeper theory we come up with better project into space-time and give us back what we know and love inside space-time. Otherwise, it's wrong. Right. So we can't know that our theories outside space-time are right, but we can know when they're wrong. We can know that this is really dumb. It's not going to work. So here's where it's fun, because the current scientific theories can't tell you what leap beyond space-time or whatever, beyond the current theory to take. So that's where the young scientists typically have fun and make creative leaps. But then you have to make your creative leap precise and then project it back and see if it's compatible with the old theories to test it. And so the leap I'm taking right now is to say, okay, there's this social network of conscious agents beyond space-time. And space-time is just a headset. It's just a user interface. So it's incumbent on me then to work out the mathematics of this social network and to precisely map it into, for example, the Minkowski space of Einstein space-time. So if I can't take my social network of conscious agents and map it into space-time and get back, for example, the standard model of particle physics and mass and spin and momentum and how the proton is made of 2 up quarks and 1 down quark and the momentum distributions of them at various q squared b. If I can't do all that, I'm wrong. And I shouldn't be taken seriously. So in other words, this is not hand wave, airy fairy stuff. If my theory of conscious agents can't predict the innards of the proton and the up and down quarks and their momentum distributions at all Bjork and x and q squared that particle physicists have found, then my theory should just be discarded. So we can't prove our theories, but we can tell you tests that will discard your theories. And that's the way science will always go. You can never know you're right, but you can put down critical tests to show that you're wrong. And ultimately, I'm saying you're not ultimately right in having in the sense of having a theory of everything. I think in principle, science can never have a theory of everything. You can't write down a theory.
Got it. But you've gained, you've become more discouraged about what you had originally perceived as reality, but without gaining more insight then as to, okay, well, this isn't reality, but here's the real reality. It's more of you've walking back. You know that what you perceive is not true, and that's it. But it doesn't give us more evidence or details about what the real truth is.
That's right. And I think ultimately it also changes what you think about the new theory that you're proposing. It's not that now I've got the truth. It's I've got a deeper perspective, but my perspective will inevitably be overthrown. In other words, I realize that all I'm doing is taking the next baby step in science, and it will be overthrown. The question is only how soon will it be overthrown? And that's what I mean when I say there's no theory of everything.
Right. But past theories, like with Einstein's theories, have given us clarity and have given us insight and perspective, and we've been able to create new things because of it. And our understanding of reality expanded because of those theories. So we thought reality was one thing. He had these theories, and our version expanded, and we now understand light more intimately. But separating consciousness from reality, it seems to kind of restrict our understanding of reality. It doesn't necessarily yet point to any ways that we can make use of this information per se, or understand the world differently. It's to add a level of maybe skepticism, right? To say, like, look, all that we think is true isn't necessarily, right?
Well, think of it, actually, on that point, I'll disagree. And I think that there's some interesting technologies, really fascinating technologies that could come out of this, practical technologies. And here's a metaphor. Suppose that you're in a virtual reality game like Grand Theft Auto, but a VR version of it, a multiplayer game. And you're a wizard. You can beat most people, you can outrace them, you can whatever. But suppose that you're a software engineer who actually knows the software behind Grand Theft Auto. You can do things that will look magical to someone who's stuck inside the VR headset, right? So the wizard goes from A to B through the space-time of the Grand Theft Auto. They have to drive through the streets. Right. But if you're the software engineer, you can actually take gas out of the tank of the wizard. You can give him flat tires. You can change the geometry of the roads, or you could actually take his car and actually make it go from A to B without going through the space. So what I see happening is when we really understand, if this idea that there's a vast social network of conscious agents outside of space-time, and space-time is just a headset that certain agents use, then that's going to open up new technologies. For example, the nearest galaxy, the Andromeda galaxy, something like 2.5 million light years away. Going through space-time, it would take us 2.5 million years to get to our nearest galactic neighbor. That's their, well, not going to happen in my lifetime or my great-great-great-great-grandkids' lifetime on us. It's not going to happen, right? So in the headset of space-time, we have some serious problems in terms of just getting to our nearest galaxy. But if we realize that the space-time is not the reality, it's a data structure, it's a headset. And we actually now understand at least the first layer behind it of software. So this network of conscious agents would be not the full software, but a layer of software that we can begin to understand and manipulate. Then maybe we can when we understand the headset of space-time well enough, we don't have to go to Andromeda through space-time. We can go to Andromeda around space-time. Just like the software engineer takes in Grand Theft Auto can actually move the car from one place to the other just by changing its location, the pointer inside the software without having to go through the space. So I see the technologies, when we really understand this network of conscious agents outside space-time, the technologies are going to be so profound that everything else is going to look like firecrackers. Everything we've had before will be trivial compared to what's going to come out of this. So it's not a negation and saying, oh, well, I'm sorry, I interrupted you.
No, sorry. No. You said it's not a negation in terms of what?
So it's not a negation saying, well, that the consciousness is, a theory of consciousness is telling us that space-time reality is not all there is, but nothing positive. No, it's saying there is new technology that's going to come out of this that's completely transformative.
Yeah. And is that possible? I mean, do you think it could be possible to find a way to get through millions of light years without? Maybe there's a way if we can figure this out. What do you have hope for that?
Well, I think that that's a prediction of our theory, frankly. That if our theory is, I mean, if that can't happen, it's probably a counter to our theory. That would be evidence that our theory is wrong. In Grand Theft Auto, if you're a wizard and that's all you know is how to drive a car really fast inside Grand Theft Auto, it might seem impossible that your car could get from A to B without going through space and time. It might just seem impossible because that's all you know. All you know is the headset. But if you're the software engineer, it's trivial to make that car just appear somewhere else.
Yeah, interesting. What would that look like then? Just having what would that require? What would someone have to do to get someone to appear in that other galaxy?
Well, so that's what we're working on right now, is to get this mathematics so completely precise that we can actually do that. So for example, to begin to answer the question you asked, we need to say what aspect of the dynamics of conscious agents corresponds to mass, what corresponds to momentum, what corresponds to particle spin, what corresponds to the structure of space-time. And why is space-time hyperbolic? Minkowski space is a hyperbolic space. Why is that the case? So we have to answer all those. And when we answer all those questions, then we will start to see the details of the software behind mass and momentum and spin and the structure of Minkowski space. We'll actually understand the software that's leading to that. And now we'll be able to tweak that software and change what's happening inside the headset.
Wow.
So there's a lot of fun
somehow tweak it.
We're working on a paper right now.
Yeah. So I think there might be a lag in the connection. Uh-oh.
There's a lag. Yeah.
Yeah. Can you hear me okay?
Right.
There's a lag. Uh-oh.
Yes.
Uh-oh. Maybe it's mine. I'll work on that. But so what would that technology look like? I mean, how could we reorient? Yeah, like what? Even if we understood it's mathematically possible, how could that? Yeah, how could we change someone's position in what we call space-time?
Well, it will probably look magical to us right now. So for example, think about someone from 1800 coming right to us right now and seeing what we're doing right now. I'm in California, you're in Massachusetts, and we're talking and hearing each other. That would seem like a miracle to someone from 1800. And they would say, you have a lot of explaining to do. How in the world are you doing this miracle? And we would have to say, well, to do this, first we had to play with a lot of magnets and wires. And we had to, and Michael Faraday and others did that. And then they wrote down equations, and then some others, wrote down even, we got all sorts of incredible equations. Then we wrote down quantum theory and special and general relativity. And finally, we got the tools that allowed us, we have Maxwell's equations for electromagnetism. We have all these tools. And once we had all this mathematical structure, we all of a sudden realized, oh, this means that we could actually invent these kinds of technologies, and we could actually have instant communication, or almost instant, at speed of light communication. So it took us many, many decades of hard scientific work and writing down mathematical before we realized, holy smokes.
In our case right now, maybe a little
a little bit slow, right? Yeah. We're having a little time lag right now. So yeah, there are glitches in our matrix, but still.
Uh-oh. Sorry about this, Don. Yeah. So right, what you're saying is that what looks like what we take for granted now will look like magic even 100 years ago. I think to people today it still looks like magic. Most people don't understand how you're able to do a real-time FaceTime where you can see and hear someone in real time. It's still magic to people. But to your point, absolutely. 200 years ago, of course, they'd have no idea how it is now. And likewise, we can't grasp now the technology of the future. Yeah.
That's right. It will look like magic to our current brains and our current understanding.
Yes. Yeah. So another random, tangential, not related, sort of related question. The wave function collapse theory, not even theory, reality of when you shoot an electron through what is it, like a split, through two slits, and the electron lands depending on the position of the electron depends on whether you are or are not observing it. And it's this, I think, idea that consciousness is literally impacting reality. It's that whether or not you're viewing the electron then affects the position of the electron. Do you have thoughts on this theory? Do you have a hypothesis as to how and why consciousness can affect the position of electron, as in the wave function collapse experiment?
Right. So
the double slit experiment.
A huge problem. Right. Yeah, the double slit experiment. So the role of the observer in the measuring apparatus is a big unsolved problem in quantum theory. Right. So when you're not looking at an electron or some particle, it evolves in the non-relativistic case according to the Schrodinger equation. It's a unitary evolution. And when you make a measurement, make an observation, somehow that particle interacts with a macroscopic measuring instrument, and the ultimate result is you get a single value, right? The particle went through this slit or that slit. You get a collapse. And that's not a unitary evolution. And that's the problem, because particles, which are presumably the apparatus in a physicalist framework, the apparatus is made out of particles. But now the apparatus is behaving in a way that doesn't satisfy the Schrodinger equation. It's doing something that's not unitary. So this is a huge problem for quantum theory, because it's a unitary evolution when you don't look, and a non-unitary evolution when you look. Now, some physicists will say, well, that's no problem. Decoherence takes care of it. And that's false. Decoherence does not take care of it. Decoherence, where you essentially get rid of the complex interference patterns. All decoherence does is to move you from a pure quantum state to a mixed quantum state, but it will never get you to the final single quantum state, where it's like up or down. So physicists who say that decoherence takes care of it, that's false. It doesn't take care of the measurement problem. It only goes from pure states to mixed states. So it doesn't get you down to the final answer. So that's a huge unresolved issue in quantum theory. Now there are the many worlds interpretations of Everett and so forth, where they basically say there is no collapse, but careful analysis shows that they still have the same problem that I just described. And there's a great video by Sabine Hossenfelder, if someone wants to look at that, how the many worlds interpretation does not solve this problem either. So that's a huge unsolved problem in physics. And so what I'm saying is, from a point of view in which consciousness is fundamental, objects in space-time are just headset items, right? So for example, if I'm in Grand Theft Auto virtual reality, and I look off to my right and I see a red Ferrari, does that red Ferrari exist when I don't look at it? No. The red Ferrari is only there when I look over and render it effectively. There's no red Ferrari in the supercomputer. You can look as much as you want inside the software of the super. There's no red Ferrari anywhere there.
So this is interesting. So I had this view when I took a philosophy course a couple of years ago, where I tried to say something similar. If a tree falls in the forest and no one's there to see it, does it really fall or make a sound? And I was saying no, because the whole notion of sound or sight or what that's all, it's only through our perception. But then the obvious counter argument to that was, they would say, Jake, are you saying that if you don't see something, it's not real? Like, what a stupid argument. If whether or not you witness something, it still happened. And you can go afterwards and see that the tree did fall. And how can you say, Jake, that, that things that exist are only existing through your consciousness? Because, for example, you could perceive them afterwards, or you could, and I couldn't really, I didn't know how to refute that, but something about the argument that physicality appears to consciousness appeals to me, but I'm not able to get around the counter argument that, well, what a stupid observation, because clearly things exist despite your seeing them.
Right. So, and it's actually easy to get to answer that. Just think about it. If you think about it in the virtual reality context, any question that people throw at you philosophically like that, just take it back into virtual reality and you get the right answer. And it's simple. So, for example, I'm playing Grand Theft Auto and I look over and I see a red Ferrari. I look away and the red Ferrari that I see doesn't exist. But my friend in China who's playing with me, he sees a red Ferrari. And my friend in Germany is also seeing they're seeing their red Ferrari, and they see it crash. Well, I wasn't looking when the red Ferrari crashed, but now when I look over, I see a crashed red Ferrari. Does that mean that the red Ferrari I see existed? No, when I wasn't looking. No, the red Ferrari that I saw never existed, and the red Ferrari that the German guy and the Chinese guy saw only existed when they looked. What's going on is a reality that looks utterly unlike red Ferraris. It's software in some supercomputer. That does exist, but nothing in space-time exists. So that's the key. It's a very, very simple move. So any philosopher who asks you these questions, it's trivial to answer every one of the questions. Just take it into VR, and the answer comes just like that.
Very interesting. So you just say, hey, it's like a video game. But let me ask this, and you said something. So you said that in order to get that red Ferrari to appear, there has to become some kind of simulation of that somewhere. Like, in other words, something has to create the red Ferrari, right?
Right. That's right.
Simulate, and therefore it does exist, right? Because it's like
the red Ferrari doesn't exist. It's a simulator that exists.
Right, but the simulation of the red Ferrari does exist. right?
Right, but what I'm saying then is that nothing in space and time is fundamentally real. Space and time is
Yeah.
just the headset, and the things exist only when you render them, and they don't exist otherwise. There is a reality that's utterly unlike space-time and utterly unlike
Yeah.
any objects inside space-time. That exists beyond space-time. But anything that you see in space-time is only rendered on the fly because it's a headset. And by the way, the Nobel
Yeah.
Prize in 2022 was given for this. The three physicists who won it for showing that experimentally that what we call local realism is false. So
Yeah.
local realism is the claim that physical objects have definite values of like position and so forth when they're not observed, and
Mhm.
that they have influences that travel no faster than the speed of light. And local realism is false, and it just won the Nobel Prize. The reason why local
Mhm.
realism is false is because space-time is a headset, and you only render stuff on the fly when you look. That's
Yeah.
why the values are only there when you look. So it's actually
In the
very easy
case,
to answer all the philosophical objections that have been out there for a long, long time. Trivial to answer them.
yeah. Well, you answer them with the metaphor of the video game, right? In other words, you're saying it's easy to answer them. And just to clarify, the response to those objections is you use the metaphor or the analogy of the video game, right? Or the VR.
That's right.
Yeah.
The VR. VR,
Got it.
frankly,
Right.
all these objections and all the trouble we're having, the next generation probably is not going to have it. They spend all their time in VR. They're going to go, of course.
Yeah.
Local realism is false, of
So
course. I
in
mean,
other words,
it's not going to be a problem for them.
but so you answer the double slit experiment theory by saying, well, of course the electron is a different place because of course it's only a rendering from your consciousness. But how come in no other instance in life can we observe a similar thing? For example, like I can't look at a tree and make it move. I can't look at a chair and make it move, but I can look at an electron and make it move. So it seems like a unique experience because we ordinarily can't observe our consciousness as altering our perceived state of some object.
Right. So this will now get into, there's a couple directions to explore on the answer of that. One is, of course, just the nature of our interface. And we often see these electron kind of phenomena when we're getting to the very sort of the limits of our interface, right? It's that they become more apparent. But we can see multi-stable perceptions all the time. So have you heard of the Necker cube?
I
So
haven't, no.
it's a line drawing of a cube. Just if you just do a line drawing of a cube and look at it on a piece of paper, it will look. You'll see one face in front, and then the cube will flip, and you'll see another face in front. So you actually, so when it's easy to, and also, for example, there are windmills like in the Netherlands. So you're driving along and you see, some building with a windmill on it, and from a distance, often you'll see the windmill spinning like clockwise, and all of a sudden you'll look at it. Whoa! What, the windmill's turned around and it's spinning counterclockwise.
Yeah.
And so these are multi-stable displays, and I've done a lot of work in visual perception, and I've studied multi-stable displays. It's very easy to get people to have these multi-stable percepts for macroscopic objects. So physicists are doing it with these microscopic objects, but we can do it with macroscopic objects too. And the source is the same. Our perception of space and time is just a headset, and we're rendering on the fly what we perceive. And sometimes the rendering is ambiguous, and we flip, like on the cube, from one interpretation of cube to another, and we actually see a flip in interpretations.
Yeah, but the windmill is an illusion that is in real time, whereas the electron displacement, like you can track it on a graph, and then you can look at that graph a day or a week or a year later and see the positions of the dots. In other words, like those electrons did land where they said they landed. Like it's not an illusion in the moment. It's data that's lasting.
Well, in our lab, we also get data on the illusions that people experience. Like I can see someone's looking at an Necker cube, I can get data. Okay, from this period to this period, they saw this interpretation, so that's data, and then it's flipped to that. So we actually sometimes measure that. We get strong data on the flipping times between interpretations. We get data there too, no problem.
Wow.
That's what psychophysics does. That's the field of psychophysics.
Well, I could go down this rabbit hole for another hour, but I know we're at time. Let me stop the recording, Don, and I'll do it. And